Hi, my name's Mike, and welcome to this masterclass on working in the terminal. In this lesson, you're going to learn about how to free your hands and work in a command line interface. That means there'll be no pointing and clicking of the mouse, only using the keyboard and commands that we learn to do common tasks on our operating system. Things like navigating, moving files around, copying files are where we're going to start. Then we're going to move into different topics like editing text, doing a little bit of data processing, and even some things like zipping up files. So we're going to cover a lot of the basics, and we're going to cover them relatively fast. But if you watch this a few times in practice as I do the commands, soon your hands will be free and you'll be able to move very quickly and learn how to automate some tasks even that normally would take you a lot of time on a graphical user interface. So what do you need? All you need is a terminal. So if you're on a Linux machine like Ubuntu, a Mac or Windows machine, just open up a command line prompt and we will begin. All right, let's start. All right, let's begin on our introduction to the terminal. And let's start off with some commands. The first command I'm going to show you is echo and then just hello, just so we have a welcoming message. I'll make this font a little bit bigger just so you can see the commands easier. So echo and then hello will print out whatever is between the quotation marks here. And what I want you to do is go ahead and type this out and modify it and say, hello, my name is, whatever your name is, and then followed by enter. Now it's important to understand that as we're going to be executing these commands, most of these commands, like echo, are actually programs somewhere in the Unix operating system, or if you're using Windows or Mac on your appropriate operating system. So these are programs, and these are the arguments into those programs that they'll take and execute. So I can run this same program with different arguments passed into it. These are the command line arguments. Okay, so we have this echo command. And echo is going to be our first command, and maybe we want to know some more information about it. So we can open up a new Chrome tab if we like and go ahead and search for echo. But I'm going to save you a little bit of time when looking up these commands if you want help. Most of these commands have a help page or a manual that is included in the operating system. So you can just type in man, which is short for manual, and then the command. And it will display a short synopsis of what the command does and how to use it. So here's the name, a short description, and how you can use it. So there's different options that we can also pass with each of these commands. So for example, with echo, we can get help, we can get the version, and we can also have certain sequences of characters ignored or omitted from our output. Okay, so that is the echo command. Now, if I asked you to type out this command many times, it might get a little bit tedious. So I want to show you a little shortcut as you're typing in some of these commands. The first is that you can start typing in echo, and you can just hit tab to autocomplete. And if there's a close match, the terminal will automatically fill it in. Most of your terminals have this ability. And then you can write the rest of your command here and then execute it. If I just hit E once and then the tab key, you might notice that there's a bunch of other possible commands that are found here. So in this case, we needed to type in C, then I can hit tab again, and it'll find the next closest match, which happened to be echo, because there's no other command with E followed. Now, if I had typed in some other command, like with an EN and then tabbed, it would again give me a shorter list of the matches and continue to reduce as I type the tab key here to autocomplete. Okay, so that's one thing we can do. Now I'm going to clear my terminal by typing in clear so that we get a fresh start. Something that will make this a little bit easier to follow is if I use the tool screen keys. I'm going to enable this just so that you can see some of the keys that I type at the bottom of the screen here. So let me repeat the exercise just so you can follow along here. So we did echo and hi, and then you can see it being also repeated by this command, and then I hit enter to enable the command. If I start typing in something and then press the tab key, you'll notice here's the tab key, but this filled out the rest of our characters here, and we can then again finish typing. And then we learned about the manual page, which can give us help about our command here. In order to quit the manual page, you can follow the directions at the bottom left corner, by pressing H to get additional help, which will teach you how to navigate these manual pages, or simply just press Q when you're ready to quit. Okay, and that tends to be a standard way of operating. So again, we've learned some essentials of the terminal here. Now, you might have noticed, and I've snuck this in a few times because I do it so often, that I can type in clear to clear the terminal before typing in more commands. I can also just type Ctrl+l and that will clear the screen as well. It's a shortcut. It's not, however, erasing all the commands. If I scroll up on my mouse wheel, it's rather just inserting a bunch of blank spaces so it appears that we get a fresh start. So you can scroll up and down and likely see most of your previous commands, or as many as your terminal will save for you. Another shortcut you can do is you can hit the up arrow key to go back in your history and see the commands that you've typed. This is a quick way that, again, if you're going to execute a bunch of commands over and over and over again, you can just hit up or down to navigate your history. If you want to see your history, you can type history and see your commands. If you want to re-execute something, you can type the exclamation and then one of the command numbers to repeat this command. So 2029 should repeat this hello here. Okay, so that will repeat this command. This is the command that was being repeated or executed, and then the result of the command. All right, so this is how we execute different commands. And again, these commands are different programs. So let's talk about where those programs come from and practice a little bit of navigation in our next step as we move through here. So we can query where this program echo comes from by just typing in which and then the program name and then enter. And I'm going to execute this one more time just so it's at the top of the screen for you. But you'll see it comes from /bin/echo. And this is the directory followed by our program name. And this is the part that takes a little bit of practice with the terminal. You don't have any sort of dialogues that you can click on necessarily in your system here. We're learning how to just do this all from our terminal. And we have to sort of build up this mental model of what directories are and where files might exist. So let's first figure out where we are and see if we can navigate this /bin/echo location where this command lives. So what we can do is type pwd. What does pwd do? Well, it gives us a link to where we are, or the current working directory. Again, if I don't know, I can type in the man command and then pwd to see that it prints the name of our current working directory. I'll press Q to exit, and again remind you that pwd is telling me where I am. I'm in my /home folder /mic and in a directory that I've created called terminal. Okay, just for this one time, I will open up a dialog box. So I'm going to cheat and show command just so you can see where we are, that I'm in this terminal folder and in home here. Now, if you obviously don't have a graphical user interface, you can't do this, but I again just want to help give you a sense that I'm in the home directory and in the terminal directory working in this area. Now, you'll notice that there are actually other files here. How would I know that from my terminal? Well, let's introduce another popular command called the ls command. So ls, if I type it out, will repeat those files. Again, I will sort of cheat and show you what I'm seeing here, but I have 3 files which are directories, and those are highlighted in blue, and then just 2 other files that contain some text information, just some small text-based files. Okay, so these directories are places where I can navigate, and files have information in them. So for example, if I want to navigate into this folder, I can change the directory with cd and navigate into this folder here. Now if I print out my current working directory, I will see that I am no longer in the terminal directory, but in this horde3d directory. So let's go ahead and repeat that on our GUI and click on it here. And we'll see we're in a new directory that has 4 other folders in it and 2 files. So I can again list the contents here on the terminal with the ls command to see the 4 different directories listed in alphabetical order and then the 2 other files that exist here. Again, let's take a closer look at the command to list the directory contents. And there are different options that we can do. Things like displaying all the files, Perhaps there are hidden files that our operating system's hiding from us. We can list in a column format, and we can list other information like when files were created. And that's something I might do often with the -L. So you can see here's the files and some information about them, such as the date that they were created and who created the file and which group they belong into. It's something that we're not going to do a deep dive into right now, but we can actually do some file access and protect our files to only belong to certain users and certain groups. So if you're on a machine that's going to be shared with many people or networks, this is what is being indicated. And this is the particular permissions for those files. If we have read access so that we can open the file, write access so we can modify it, or execute access if this is an executable file, meaning we can do some action on it. Okay, so that's been interesting to explore some other files and directories, but let's go ahead and think about creating our own. So how do I navigate backwards? Well, I can use the cd command and hit ... and that will move me up a parent directory. So before I execute that command, let me just remind you where we are, and I'll do cd ... and that'll move me up my directory in pwd to where we are. Okay, so let's not also forget what our objective was, which was to find that echo folder. So I can say which, again, echo, and where was that? And then I can cd to this location. And this location that I have here is the absolute directory. Okay, that is, if I look on my folder, the full path to get there, and we can sort of think of this as a URL if you're used to navigating the web, but the full path to get there is in something called /bin/echo. Okay, so I can cd into /bin/echo, and or rather just /bin, excuse me, and I should be able to see when I list the contents that echo is amongst these files. So I'm going to slowly search through here and find that echo is in fact part of these files here. Okay, so that's pretty neat. We found where this actual program exists, and in fact, some other programs that we've been using like ls to list the contents here. Okay, so where am I? I'm in bin, and I might want to move back to where we were so we can continue our exercise and do cd and a minus, and that'll move me back once to my previous location. So again, I am back in my home, mic, and terminal directory. Okay, so let's talk about creating some new files in our system, because that's something we might want to do, create new files and directories. So I'm first going to create a new directory, mkdir, which makes a new directory, and I'm just going to call it exercise. And I'll list the contents here and see that we have this new folder here. So let's navigate into the exercise folder, and I'll again confirm that we've moved there and list the contents. Well, it's empty. And if I do ls with -l to get the long format, you'll again see that nothing is there. I can do the AL format to list all the files there, and you'll notice that there are indeed a dot and a ... when I list the hidden files. Remember that ... would move me up a parent directory, so back to the terminal directory here. So if I cd ... that's really just moving me back up a directory. And there's a hidden file that indicates this that's just called ... So when I'm cd ... it's just moving me up this directory here. The other file, cd ... is my current directory. So if I do cd ... that doesn't move me anywhere, but it will allow me to navigate from this location. Okay, so I can either navigate my full path. So let's go ahead and just copy this full path here. I'll copy it and paste it in here. And this will perform the absolute file path and navigate me to this directory. Or let's cd back. I can navigate a relative path. So from where I am in the terminal directory, I can do cd ... and then /exercise. So in a way, that's just appending this location plus where the dot takes off this location. And that'll move me to this next file over. Okay, so that is essentially what we're doing. And I can specify this in different ways, or I can add other directories, but from my current location, where do I want to navigate to? That's what we are doing. Okay, so now we know a little bit about navigation and moving around in files and creating new directories at this point. So let's continue, and let me clear the screen here and talk about creating some new files here. Okay, so what I'm going to do is use the touch command and just create file 1. So if I list the contents, we'll see that we have file 1. It was created at right about this time, matching my clock here. If I want to open this file, there's a few things that I can do. I can just output the file with cat, which will output the file. So let's look at the manual page for cat and see that this command can concatenate files and print to standard output. So if I just specify one file, it's just outputting one file, but it's empty. So let's add some contents. I personally like using the Vim editor, but it might be a little bit intense for this introduction. So I'm just going to introduce Nano, and then I'll do the same thing in Vim. But Nano is a free editor, so you can type in Nano and just type out some contents. This is our first file that we have created, and I'll put a period. Then if I look at the bottom here, the up arrow here indicates Control and then X. So if I hit Control X, it will exit. It's asking me if I want to save, and I'm just going to type in Y to save and then enter. And then now I can do Control X again and hit Y to save, and we should be all set here. Actually, it's asking me if I want to write out the file here, so let me do Control O, and then it wants me to add a option to either append to this file or modify it, or specify a new name here. I'm just going to give it the name file1, which already exists, and then overwrite it with Y. Okay, so now let's exit. I prefer using Vim. So if I do file1 and open it in Vim, I hit I for insert mode, and then I can also modify the file again, and then hit escape, colon, W to write, escape again to enter the command mode, colon, and then Q to quit. Okay, so that's another popular editor, which I have other lessons on if you want to get started with Vim. Okay, anyway, we've created a file, and frankly, that was a lot of work. So let's copy the file using the command CP, and I'm going to copy file 1 and call it file 2. Okay, and then if I ls, I'll have my second file here, a new copy of it. Now you'll notice I did something a little bit sneaky when I started typing out the command. If I hit tab, again, it will autocomplete up to the point I can do it, and then I can type either file 1 or file 2, whichever I want to copy. So let's copy file 2 and create a third file here, and then enter, and then list the files out here. Okay, I like using these sort of shortcuts to speed things up, like tab and autocomplete. Okay, now that we've created a file, let's go ahead and give ourselves something a little bit more interesting to work with and create another directory here. Let's just call this directory directory 1. So we have another directory here. So now we have 3 files and our directory. And what we're going to do is move a file around. So instead of having to do this in our graphical user interface, which we're used to, we can actually just move files with the mv command. So I'm going to move file 1 into directory 1. And then if I ls, you'll see file 1's gone, and I'll move it into directory 1, or excuse me, I'll move into directory 1 and list the contents here, and we'll see file 1 is there. And then I'll cd to move back, clear my screen, and then list our contents so we can see where we are. So at this point, I now have a couple of interesting files. And I can output these files, file 2 and file 3, and this will write them out to our standard terminal. If I want line numbers to make things a little bit clearer, I'll hit the up arrow, and then I'll hit Ctrl+A to move to the start of the line, and delete this concatenate command and just put NL, so it will also do that same concatenate operation, but it'll give us line numbers here. So we can actually see that we put together those two files and that there are 10 lines. If we want to not count these lines manually, we can also use other programs to help us with this task. And this is really where the terminal gets powerful, in that we can compose commands in a way that we can't easily do so in our graphical user interface. So this idea that I'm going to show you is, let's just go back to our cat command. I'll clear the screen. And we have these files here. In fact, we have a bunch of lines that were printed out. There's another handy command. It's called wc, which will count the number of lines or words in a file and print them out. So let's say we wanted to just figure out how many lines were in file 2. Well, the first output is how many lines here. But what if we wanted to find out how many lines there are in both of these files without counting? Well, we know that this outputs a file, but we can actually concatenate this output and send it to the next program by using a pipe. And this will send into the output these 10 lines from these two files as the input into this command, which counts how many lines there are in the incoming output here. So if I do wc, now we can see that we've counted that there's 10 lines here. That's what this tool does, word count. It counts how many lines are incoming. And then it also gives how many characters and then how many bytes that is. So that's kind of cool that we can sort of pipe commands together and do this sort of processing. In fact, this processing is very powerful because we can start to do more interesting tasks. So let me modify file 2, if you will, and I'm just going to put in some random characters here. A, B, C, F, Z, Q, just some letters here. And I'll write this file and quit. I'll modify file 3 as well. I'm going to delete this file quickly here, Shift V, G, capital G, D to delete. And then I'll just add some other letters here like X, Y, Q. Then I'll hit X escape, colon, W to write, and then Q to quit. So now I've got these two files that I've modified. Let's go ahead and display them. File 2, file 3. Okay, there they are. We can also pipe this output to word count to figure out and confirm, yes, we have 9 lines, as our NL tool does. NL counts the number of lines. But now let's go ahead and let's figure out if we wanted to find all these files and then alphabetize them, for instance. So again, we can get into some interesting processing here. I'll clear this out. Let's look at our files here, file 2 and file 3, and we have a command for that to sort them. And if I do sort, you'll see that we get these sorted based off of the first character in each line in alphabetical order here. So this is really cool, and we can do a little bit of processing here. And in fact, this idea can be very powerful, that we probably want to work with some of our data. And in fact, let me make this, if we have a lot of data that we particularly want to look through, we can look through it in different ways. So let me exaggerate this example just a little bit and provide the same file over and over and over again, just to show how it can be sorted here. Okay, so we see that it is, in fact, getting relatively long if we just keep concatenating these files together. If our output does get very long, we can pipe again to a command called less, and this will allow us to just hit enter and scroll through the data. Let me give it a few more fields here, just so we can see it here. So if I hit enter, you'll notice I'm just moving one line at a time. I can also move up and sort of scroll through this data. I can actually search for this data if I hit / and then A, and it will attempt to look for a pattern. If I do, if I scroll up enough here, or /B /Q, and then it'll highlight all the Qs, and then I can just press Q to exit. So again, just to recap, what I've done is I've outputted all of these files that we've created here, and it writes them all out into one place. I've sorted the data, and then I have another command here called less, which allows me to sort of navigate this data in an easier way. Because before, if I'm just printing it out to the terminal, well, then I'm done. But I can actually explore the data and search it with this less command. Okay, so that can be a powerful command for us to use. So let me expand on this idea a little bit, and I'm going to bring in from my web browser here some data here. So what I have here is a basketball reference website, and this is Michael Jordan's stats here. So let me reload the page just so you can see what this looks like. It has stuff like how many points he scored per game, how many rebounds he had, how many seasons he played, and so on. I just want to show you again how we can do some of these powerful tasks here of looking through data. So I'm going to get this table as a CSV file. That's a comma separated field. So every one of these fields is separated by a comma. That's how I know I'm reading in the next sort of column of information. And let's bring this in as an exercise. So I'm just going to copy it. And let's move back to our terminal here. And in the Vim editor, I'm just going to call this mj.csv. I'll hit :set paste is the command I want to do. I for insertion mode. And then Ctrl+Shift+V paste data in Vim. Escape, W to write the file. Escape, to enter another command, Q to quit Vim. Okay, so now let's go ahead and just output this data to see that we have it output, and it is here. And it is very messy. We can try to explore it again with our less command here, but this probably isn't the right tool for exploring here as I hit enter a bunch of times. So let's see if we can clean up this data a little bit. So what I have here is MJ's data, and I know I want to write it out in some way. So a very handy command that I can use is the cut command. So I'll look through cut, and you can think of it as an ability to remove sections from each line of a file. So if you have data that's formatted, the cut command can be very useful. And we've learned how we can pipe information. So from one output of a program will be the input to the other. So we want the input to be cut here. And the cut command works by taking in different delimiters. So -d is the argument, and then the comma is going to be the delimiter. That's what indicates a new field. And let's say I only want a few of the fields, fields 1 through 4. And then I hit enter. So this now just shows the first 4 fields and the comma separated information of that data here. So the season, how old Michael Jordan was, what team he played for, and what league he was playing in, if any league. Okay, he retired for a few seasons, so that's why some of this data is missing. But now we have this very powerful way where we can parse this information. And if we like this investigation that we've done here, we can actually write it out to maybe just mj4.txt. So remember, it's just the 4 fields. And now let's go ahead and output that. I'm going to use the new line command, mj4. And we can see we've written out, so with this arrow is how we can write out data that we would normally be printing out, but actually save it in a file. Okay, so that's pretty cool. And maybe we do another one of these investigations. Let's do another one, and let's call this MJ. Let's see if we can figure out which field holds the points. Maybe it's field 9 here. Nope, that says field goals. I'm going to take a few guesses here. 3-point percentage without counting them. There's a lot of fields in here. 33 is too big, so we have to try again, so it just outputs nothing. 21 is his free throw percentage. His assists, okay, we're getting a little bit closer. 28, so you can see how I can very quickly just explore this data here. 29 is his fouls. Okay, let's speed this up a little bit. So through 32, okay, field 32 looks like it's his points, or rather field 31 here, or maybe 30. 30 it was, the last one. the last column of information. Okay, so let's also write this information out, and I'm just going to call mj points.txt. Okay, so now if we look at the files that we've created, we've got all of his data and then some of our investigations. And now maybe I want to send this information to a friend. Okay, so I can email each of these individual files perhaps, but again, we're doing things in the terminal, so we want to figure out what we could do here. So some things that we could do are, for example, we could put all this information into one archive, if you will. So I can tar the files together. Okay, now it's getting a little bit hard for me to show you these commands and sort of keep switching back and forth. So I'm going to introduce something called Tmux, which is a terminal multiplexer. And what that means is as soon as I hit enter, you're going to notice this green bar that shows at the bottom. And that's going to allow me to split my terminal into two windows. Otherwise, my option is I could open up another terminal and sort of show you the help. But I want to show you how to do this in two different windows just to get you excited about it. So I'm going to hit Ctrl+B and then the quote mark to do a horizontal split, or maybe I don't like that, but now you can see that I have two windows here. So I'll hit Ctrl+D, I'll hit Ctrl+B again. That means enter a command in Tmux, and then the percent sign, and that'll give me a vertical split, which looks a little bit better to me. And Ctrl+B and then an arrow key will move me between each of these windows. Okay, so now let's go ahead and continue our investigation where I was going to combine these two files together in some way. And I was going to use a tool called tar. So now I can look at the man page on the right side and show you this information. So again, what I have here is our tar, which is an archiving utility. So it's a way to basically put a bunch of files together. It's like a zip file, and you can actually compress the files and so on. But let me just show you the commands so you can see them. So tar here, what it will do is if I pass in some arguments to this command, C to create a new file, V if I want the sort of verbose output, and to choose the file name here. And I'm just going to call this mj.tar. And the files that I want to include. So the mj, the first 4 rows that we did, and his points. Okay, and then I'll hit enter. And we'll see that these are the two files that have been created in our mj.tar. Okay, now let's go ahead and practice. Let's move this file into a new directory. So I'll make a new directory here. Let's call it mj. And let's cd into that mj directory. And I'll hit ls just to see where we are, pwd. And let's move that file, that tar file, into this current directory. So how can I do that from my current directory? Well, let's move up a parent directory, so where I currently am, / I can hit tab to give me a preview of what I see, and the mj .tar file. And I want to move it, well, where do I want to move it? I want to move it where I currently am, so just the dot, the current directory. Okay, so if I do that, I have mj.tar, and it's in our current directory here. And now that I have these files here, well, let's actually just extract those files out again into this current directory. So the option to do that is actually -x. So I'll do Ctrl+B, move to the right window here, and I'll search through this. I can hit enter to sort of search, or space to quickly look through the help. And we'll want to get practice at reading through these. Maybe not all at once, but again, it can be useful to search through these pages. I can also do a / and then -x, and that will sort of search for all of those instances. So I can hit /-x, or keep hitting enter here with the slashes, and that will sort of move me through all of the times I find the -x option. So this is a great way to search. Uppercase X does something different than lowercase x. So let's see if we can find this here. Looks like it wasn't found, so I have to use star to go back up. But I'm just going to quit. I know it's -x here. So let's use tar -x. I want the verbose output, and I want to specify the file name that I am extracting, and it is mj.tar. So I'll hit enter, and it's going to extract those 2 files into this directory from our archive. Okay, just to show how to sort of combine files and then how to extract them from the tar. Everything still exists in here. This hasn't been modified, but we've gotten the data out here. So again, if we look at the MJ points here, we'll see that's the exact same data. Okay, so at this point, again, we still need to get our data to our friend. And there's a couple options we have depending on how our friend can access the data. One thing we can do is we can use a program called SCP to securely copy data back and forth to our friend, wherever they might be. So if they have a server or a domain, we can actually send them this file that way. I don't have a SCP set up, so I mostly just want to make you aware that this command is one way you can do it. Likely you put this on a file server, but you also have other commands like rsync, which will do the same thing. If you know the exact IP you need to send this to your friend and the location, you can actually do that between systems, which is super cool. Okay, so that's just a couple really what I find interesting things. I want to start wrapping this up because we've been going for a while here, and just show you one thing that's not as related but will be important for your terminal and just to understand what processes are executing. Okay, so a little bit of process management. We'll take a little turn here, but if I type in the command top, and I'll do it in the left here so you can see what top is, it displays the Linux processes that are running here. So let me go ahead and run top. Then you can see all the different programs that are running. For me, they're probably mostly Chrome, but you can see there are certain resource usage and these sorts of things, how much memory they're using, which user is running them, and so on. I think that's a super useful command to know about. You can sort of reveal what those commands are by just typing in PS, which will list some of the processes immediately running, or all of the processes for the user that are executing. That's another way to get a list of that. Those processes. Top is just a tool that'll update it every few seconds, so it can be kind of handy. But I'm going to do something a little bit silly here, and I'm going to write a quick C program that runs an infinite loop here, just to show you how to terminate processes that are long running. So let's go ahead and just write a little C program here. This is outside of the scope of the tutorial that just prints out hi every once in a while. And let's include some other things here to make it sleep every 1 second after it prints out hi. So I'll just compile that really quickly. And it wants another header file here. And I believe it wants the Unix standard header file here. So I'm on a Unix machine. Obviously, if you're following along on Windows, you may or may not have that. But if I run this program, it's just going to print hi once and terminate. But we want it to run in an infinite loop here. So I'm going to go ahead and put this in a loop that will never terminate. So this is typically, this may or may not be the functionality we want in your programs, depending on if it should be long running. So I'll recompile it and rerun it. And we're going to see that this program is just running indefinitely. It's not terminating. I don't get a new line here. There's nothing really going on here. So maybe I want to investigate this program here. If I hit enter, it's kind of a mess. I get all of my different programs here. But I can remember pipe, and I can look for or grep for maybe this infinite program. Let's see if we can find it. And in fact, we can. Okay, let me make this a little bit smaller just so you can see the all of the outputs here. And I'll do this with the bigger font. But we can see that every process that's running on our Linux systems, whether it was just those little programs we ran and only existed for a short time, or the ones that are currently running have a process ID. So this 5535 is this infinite program here. Okay, and because it's running indefinitely, I might want to kill this process. See, if I hit enter, it's not really responding. So I can do this, I can send a signal to it directly by hitting Ctrl+C, and that will directly terminate this process that is running here. Okay, so if I look at this process here, let me put a new line character here just so it prints out here and recompile it. So let's go ahead and run it again. So you'll see it's doing the high now every 1 second. So again, Control-C is one way that we can terminate that process. But sometimes you might lose control of it. So if you can open up another terminal, you might want to know what that process ID is. So let's look at all of our user processes that are executing and then grep for the program name. It has this ID here, 6067, and I can end that process with kill, 6067. Okay, and you'll notice that sent that same signal, that same Control-C to that process and terminated it. Okay, so I think with that, we've gotten pretty far and we've learned about navigation, we've learned about creating files, moving around files. You've seen some of the text-based editors that we can use in our terminal, Nano and Vim. You've seen how we can combine commands with things like pipes. You've seen how to now control and stop processes. So we've seen a lot in this little time, and you've learned a lot of different shortcuts, like how to use the history. For example, you've learned about a little bit of data processing. You've learned about tar. These are a lot of the common things that you may need to do. Now, I know this lesson went by fast. I hope you can practice along with it as you go. And that it was very useful for you, and there's so much more to learn. You can challenge yourself to learn a new terminal command every day, right? Just where we started. Do that which to figure out where the command comes from, or perhaps even just list out all the commands in bin, and these are all, the different commands that we can use. You can try to learn about what those are, and of course there's many, many more in it. But if you sort of check off which ones we've learned here, there's a bunch. Okay, so thank you for joining me. This lesson ran a little bit long, but again, I hope it was of high value and you can rewatch it if you get stuck on anything.